Hello everyone, welcome to Drawing Hub. This is Sanjana and today we'll be continuing with the part 2 of distributed computing. In the previous session, we have discussed about the basics of distributed computing, distributed systems and the features of distributed systems. Do you remember what the features of distributed systems was? We had no shared memories there is no common physical clock, geographical separation, autonomy and heterogeneity, and we have discussed all those things. So if you want more clarification on that topic, please watch my previous video. And now moving on to the part 2. This is the relation to computer system component. So from the figure you can see that there is a communication network. It can be a wide area network or a local area network. There are processors and memory bank, and the distributed system connects the processors by a communication network. Each computer will have a memory unit and a processing unit, and the computers are connected by a communication network. And this diagram is this figure is the interaction of the software components at each processor, which we'll be learning now in detail with example. So you can see here there is a distributed software which is also mentioned as a middleware library. What exactly is this middleware library? The question comes. So for that we can take an example. Let us say we can take a scenario where three friends are working together. Okay, there are three friends working together, A, B and C. Okay, and A uses a laptop Dell and the operating system used in Dell is Windows. B uses MacBook, the operating system in it is Mac OS. And C uses Lenovo, the operating system is Linux. Now they want to share the files and work on the same project. They are working on the same project, so of course they need to share files. So will it work automatically? No, it won't work automatically. Why? Because each operating system behaves differently. Each has different system calls, different file system, different communication method. So someone has to hide these differences, and that someone is called middleware. So middleware is the distributed software that drives the distributed system while hiding platform heterogeneity. That might sound scary, but let's simplify that. We'll take another example. Think of middleware as an interpreter. For example, take two people. There are two people, one speaks English and the other speaks Japanese, and they cannot understand each other. A translator comes in at this time. This translator knows both English and Japanese. So the English person will speak to the translator, and the translator will translate it and tell it to the Japanese person in Japanese. So here, because of the translator, communication is possible. So that translator makes communication possible. And middleware also does exactly the same for computers. We can take another example of Swiggy also, where Swiggy restaurant and customer. Here Swiggy is acting as the middleware. As you can see here, there is a layered architecture. Every computer looks roughly like that only. There is an application. See, distributed application. There is a middleware, and the middleware is connected to the operating system. Then there is network and hardware. So application does not usually talk directly to the network. They talk to the middleware, and middleware is the one which handles the communication. You can see that clearly from the figure, right? So why we need middleware is that without middleware, computer, see there is computer A which uses Linux, B Windows and C Mac. They all would communicate differently, and programmers, they will have to write separate code for each operating system, and that would be a nightmare. And this is why middleware is used, because middleware gives one common interface for all these. Okay, so the distributed software is what is called middleware. Now, say if your application wants to send a message, so they do not have to worry about all this Linux command, what would be the Windows networking, what would be the TCP details or the buffer. Then you don't need to worry about any of these things. Just have to call the send function, and middleware will handle everything which comes underneath that. Okay, that's why we use middleware. And one important thing you have to notice that is that middleware does not include is HTTP, FTP, telnet, mail, and all those. Why? Because these are application protocols and they are not middleware services. And middleware, okay, remember all these HTTP, FTP, telnet, and all, they are all application protocols, not middleware services. And middleware mainly provides things like message passing, remote procedure calls, remote method invocation, reliable communication. We'll see that in detail. Okay, that is about middleware. Then motivation of distributed system. What are the motivations of distributed system? Differently distributed problems. So some problems are naturally distributed. Like let us take an example of bank transfer. You want to transfer an amount to your friend's account, so you will have your money in your bank server A. When you're transferring, that money will be transferred to bank server B, that is your friend's account. Here what happens? Money has to move between different servers and no single computer owns everything. The distributed system becomes necessary here. Second one is resource sharing. Resource sharing, imagine your college has one expensive 3D printer is there. So instead of buying one for every department, everyone shares it over the network because that one is very expensive. You don't have to go get it for each department. Same idea is in computing, like resources like printers, databases, storage, GPUs, they all can be shared. An example is Google Drive. Millions of users share Google's storage infrastructure. Just like that. Then access to remote data. Access to remote data. Suppose you are in Kerala. And you need to your data is stored in London. So instead of copying the entire database to Kerala, you simply access it remotely. And the distributed system is the one which makes it possible. Then comes enhanced reliability. Imagine YouTube has only one server. If it crashes, everything stops. Now imagine there are 1,000 servers. So if one crashes, 999 are still working. This is called fault tolerance, and this is one of the biggest advantages of distributed system. Then better performance. Suppose you have to process 10 lakh images and there is only one computer. And one computer will take 10 hours to process this 10 lakh images. If you have 10 computers, each processes 1 lakh images. As the number of computers increases, the time decreases, right? The work finishes much faster. This is called parallel processing. Okay, this is called parallel processing. Then comes scalability. Imagine you are online shopping website, you have an online shopping website and that suddenly gets 10 users. Okay, there are 10 users. After some time it'll be 100 users, then after some time it becomes 10,000 users, and then 10 lakh users. So if there is only one computer, can it handle? No. Just like that, distributed system allows us to add more computer as the demand grows, and that ability is called scalability. Then comes modularity. I've already mentioned about Netflix in the previous session. So suppose Netflix has recommendation, billing, streaming, login. So instead of one huge program, each part can run on different computers, and that makes maintenance easier. So that is about motivation, inherently distributed computation, resource sharing, access to geographically remote data and resources, enhanced reliability, scalability, modularity, and incremental expandability. So in this video we have checked what middleware is and the motivation. In the next video we'll be learning about primitives of distributed communication. So that's it for today. Bye bye.